Hi guys, welcome once again to our class. In our today's class, we are going to still be continuing with Jamb uh, past questions. As you can see on the board there already. So, without wasting time, let's see what we have. During the electrolysis of copper 2 sulfate using platinum electrodes, if litmus solution is added to the anode compartment, A, the litmus turns blue, but no gas is evolved. B, the litmus turns blue and oxygen is evolved. C, the litmus turns blue and hydrogen is evolved. D, the litmus turns red and oxygen is evolved. E, the litmus turns red and then becomes colorless. Okay, now which options is correct? Now this has to do with electrolysis. Electrolysis, I know that I spent time to teach electrolysis, and by today, I shouldn't expect anybody to start beating his or her body looking for the answer. If you did not watch what I taught, go back and watch. So, okay, now electrolysis of what? Copper 2 tetraoxosulfate 6. Now, if I want to answer this question, I will start by this is copper 2 tetraoxosulfate 6. Don't mind our jam the way their question comes. Copper 2 sulfate means what? Copper 2 tetraoxosulfate 6, which is what? CuSO4. Electrolysis of this man, you know that you are dissolving it in what? H2O. Okay, now let me let you know that when you dissolve this in water, this is the form that it will look like. So the Cu will detach itself from SO4, and then you have Cu2 plus and what? SO4, 2 minus. In water you have H, water will detach itself to give you this and what? OH minus. So if this happens, these are the four ions that you have in that electrolyte. So that by the time you run in electric current into it, something will get out from the electrolyte. Okay, so now they're saying using what electrodes are all platinum, meaning they have no influence on the ion that will be discharged. Okay, if litmus solution is added to the anode, you know what litmus does to acidic solution and basic solution. If litmus solution is added to the anode compartment, they said one, A, the litmus turns blue. Now, before we now know which option will be correct, let's see what will happen. When you connect electric current, then at the anode, we have to know what will happen at the anode. And what happens at the anode? Remember, anode is the plus. Anode is plus. The positive electrode is anode, while cathode is what? Negative electrode. So like charges like charges repel, unlike charges attract. So since this is anode and positive, these two that are negative will migrate down to that side. So When on getting there, they will struggle on which one will be discharged. Since the electrode is inert electrode, platinum is inert electrode, it will not influence which one will be discharged. So they will now follow their rules. Who is more electronegative will remain. Who is less electronegative will leave, which is this man is less electronegative, so it will leave the solution by giving this excess electron to the electrode, to the anode, and then turns what? That will now be OH minus. Donating this electron, it becomes OH, and that electron will flow to the cathode. Another one will do same. So two of them will react to form. Take hydrogen here, add to this place, you have H2O. And what is left? O. So this is what you have. And another set will do same. Then you also have like this. So our concentration will be that oxygen and this one. They will now react to form O2 gas. This is a gas. That's what will happen at the anode. Then at the cathode, which is negative electrode, what will happen here is that the electrode will collect the electrons that are coming in, the ions that are left. This is negative, so this and this that are plus will move down there, and then they will contest. This has higher concentration than this, and they are very close. So that's the reason it will be discharged by collecting. Each will collect 2 electrons from the electrode, and you have Cu2 plus 2 electrons to give you Cu solid. This is what happens at the cathode. So this man is also leaving the electrolyte, whereby you have this and this, they are still intact in the solution. And remember, CuSO4 is salt solution. Now, after a long time of running in electric current through the solution, you now see that this is leaving the solution, this is leaving the solution, leaving you with H2SO4. So this and this are still in the solution, and the solution gradually turns to what? To acidic. Remember that acids turns blue litmus paper to red. Now, when we check the option that will tell us that the blue litmus paper will turn red, that means we will take that as number 1 criteria in getting the correct answer. And number 2 is when you check at the anode, what gas is given off? Oxygen. Oxygen gas is given off. That means oxygen gas is given off, and the solution, the blue litmus turns red. That's what will give us the correct answer. Let's check. A, the litmus turns blue. No, without even reading further. It's not turning blue. B, the litmus turns blue. Again, I leave that at that point. C, the litmus turns blue. Let's check another one. The litmus turns red. Yes, let's hold on to that first. Turns red. And oxygen is evolved. Oxygen is given out here. And the solution turns, since it is acidic, it will turn litmus to red. So let's take that again. The litmus turns red and oxygen is evolved. That's the correct option. The litmus turns red and then uh, becomes becomes colorless. So D is the correct option. I believe you enjoy the class. You are following the class. Okay, so I want to give you something to do. Now your assignment. The IUPAC names for the compound CH3COOH and CH2 double bond CH2 are respectively A. Acetic acid and ethane, B. Ethanoic acid and ethene, C. Methanoic acid and ethylene, D. Ethanol and ethene, E. Acetic acid and ethylene. Check the correct um, option and drop. Let me comment on your answer. I believe you are enjoying the class. It's becoming more interesting. And I told you to keep on following the channel, share the channel with your friends, comment, like the channel, introduce your friends to it. Thank you. Till we see some other time.